types of relations. So first thing is, under this types of relation, the first relation that we can have is void relation or null relation. Void relation, or you can even call it as a null relation. So what is meant by a void relation? It is something like, I am there here. I can just clearly say that Elon Musk, I have seen Elon Musk. So if I say that I have seen him, but do I have any relation with him? No. He is a celebrity. I can just understand that he is a celebrity. I know him and I have studied his biography and I am a very big fan of him. Only that I can say. But I cannot say that I am a relative to Elon Musk. This is what? We have two sets, but if they are not related to each other, the elements of the two sets are not related to each other, then we call that function, that relation as a void relation, where no sets of A is related to any set of A is a void relation. Now, the next thing is, after the void relation, we have a universal relation. Universal relation. So what do you mean by this universal relation? And you need to be very clear. If I say relation on A, it means, I had actually told you, for a Cartesian product you need to have two sets A and B. So you should never get confused, only one set has been given here, only set A is given here. So relation on A means it is something like A cross A, relation on itself, that is A cross A. So a relation R is said to be a universal if each element of A is related to every element of the set A, then we call this relation as a universal relation. Then comes the next one, that is identity relation. What is meant by an identity relation? Identity relation is that a relation R on a set A is said to form an identity relation if IA is equal to A comma A for all A belongs to the main set A. A belongs to the main set A comma A for all A belongs to A. This is an identity relation. That is, it is something like the element which you have here as A, so you should have the same image A itself. This is nothing but an identity relation. Now, the next type of relation is a reflexive relation. So, what do you mean by a reflexive relation? What do you mean by this reflexive relation? I always keep saying reflexive relation is something which is an extended part of an identity relation. What does it say? Reflexive relation says that if R is a relation on a set A, then A comma A belongs to R for all A belongs to A. If A is a set, A comma A belongs to R for all A comma A belongs to A, the main set. You can ask me a question, ma'am, don't you feel like reflexive relation is similar to the identity relation? Yes, reflexive relation is similar to an identity relation, but it can have an extended part. For example, if I just take A is equal to 1, 2, 3. Now, I can just write a relation saying 1 comma 1, 2 comma 2, 3 comma 3. If only this much is written, it is an identity relation. If I have an extension, say 1 comma 2, 2 comma 1, this is a reflexive relation. This is a reflexive relation but not an identity relation. An identity can be a reflexive, but here in this case this is not an identity relation, it is a reflexive relation. 1, 1, 2, 2, 3, 3, 1, 2 and 2, 1. This is a reflexive relation. Now the next thing is symmetric. I always keep giving an example to the students. From college to your house and from your house to college is nothing but symmetric. That is, if R is symmetric on a set A, then A comma B belongs to R should imply B comma A also belongs to R. For all A comma B belongs to the main set A. For all A comma B belongs to A. That is, A comma B must imply B comma A. From your house to college, college to house. This is symmetric. Next comes the transitive. Next comes the transitive relation. What does the transitive relation say? It is something like A comma B belongs to R and B comma C belongs to R must imply A comma C belongs to R. So I always keep telling the students about this. A student will be there. Student says, he says to his lecturer, "Sir, I like your teaching and I love you so much. You love your daughter so much." So it says that I love your daughter so much. Fine. So A comma B belongs to R, B comma C belongs to R must imply A comma C must also belong to R. For all, this is very important, for all A comma B comma C belongs to the main set A. This is what is transitive. If all of these conditions, that is reflexive, symmetric and transitive, are satisfied, then we call such relation as an equivalent relation. When reflexive, symmetric and transitive are satisfied, we call such relation as an equivalent relation. Now my next question is, I just want to wind up this class by putting you a question. So the question says, can a identity relation be an equivalent relation? Just keep thinking and keep waiting for the next class. Let me answer this in the next class. I want you all to put an effort in understanding this. Can an identity relation be an equivalent relation? With this, I would like to wind up this session and meet you all and hope for the best in the next class. Thank you. Bye bye.